Hey guys, in this episode we are going to discuss about some of the scientific calculations that are available in Python. Before going into that, still there are some more trigonometrical functions which are available in the math module itself. If you want to know what are all the important modules that are available inside this math, that's quite simple. You can just go to Google and just type math module in Python. And the first documentation you can go through. So you can see n number of things like math.sil and this math.com we have tried, but it is not executing. There are some things which are recently taken out. That's what they have mentioned, like new in version 3.8. So there are some changes actually happened when they changes the versions. So certain things cannot be implemented, but however, if you serve much, you will get an alternative for that. Copy sign, fabs, factorial, floor, f mode, expression, sum. There are lots and lots of valuable functions that are available. So when you get time, you can go through that, and based on your project need or based on the need of your task, you can serve them like trigonometrical functions. We have angular conversions, hyperbolic functions, lots and lots that are required for an engineering graduate in the real-time scenario or given inside this math module. So think about the trigonometrical things like sine, cos or tan. Print math.sine. We have to import math module. Already I have ran that code, import math, in the previous episode. So I am continuing from that. So I am not going to run that again, import math. So straightly I am writing math.sine of 90. We know sine 90 is 0. Math.log of 10. I am writing the value of log 10 of 2. It's 0. So we'll be getting the corresponding log values. Log 10 of h. 0. Then what is the log value of h? 2.07. So this is how the log values are given. And now let's concentrate about the radians. We know the value of pi is 180 degree. Value of pi by 2 is 90 degree. Now if you pass a value, I should get a radians. Radians are nothing but value of pi. For an example, let's make use of this code. Math dot radians I'm passing as 360. Print math.radians. So 360, it is giving me as 6.2831. So the radian values, it is actually giving me the radians value of 360. And for 180, pi value, the value of pi is 180, which is nothing but 3.14. 360 means 2 pi. 2 into this 3.14. That is what we actually received for 360 degree. This is the way we convert any number into a radians format. Okay. Now let's say another example. So math.radians, math.log, math.log, then all these are available inside the math functions. Now we're going to enter into some complex oriented calculations which are available inside the module cmath. Before that, let's understand about a complex number. What is a complex number? A complex number is a combination of a real and an imaginary part. Going with your 12th standard max, a plus ib, x plus iy. X is x and a are real parts, and the imaginary part is nothing but it also has an angular form. It does not have a real value. So complex numbers are also utilized in calculations of current, voltage or resistance. Complex numbers have some useful mathematical properties that actually make your life easier when you start modeling systems in sinusoidal inputs. Every non-zero complex number can be expressed in terms of its magnitude and an angle. So angle is for the imaginary part. Magnitude is nothing but the real part. This angle is sometimes called as a phase or argument of a complex number. So what are the functions available? Phase, polar, rectangular. Let's see all of this. Let me write a code. First thing is we will be writing import cmath. Import cmath is the math module for performing complex mathematical calculations. After this, I will write a print statement whereby first let me assign one complex number. Say like com is equal to 2 plus 3j. Normally in maths we write as I, but here you have to write it as j. Okay, this is my complex number. Okay, from this complex number I am going to calculate the phase. Phase is nothing but the angular form, the angular value for the given imaginary 3i. So I am going to write it as cmath dot phase of this complex number com. Let me copy this. Okay, let's see what will be the output. So the phase value, the angle value for this 3j imaginary path is 0.98. Okay, next let me calculate the same for phase I have calculated. Now I am going to calculate something called polar. So we are going to take the polar values. What is the polar? A polar form of a complex number is another way to represent a complex number. We find the real and complex components in terms of r and theta, where r is the length of the vector and theta is the angle made with the real axis. So in order to get the polar form, we make c dot math polar. Let me run this. So I am getting the real r value and the theta value. So for a complex number I have calculated the phase. For a complex number I have calculated the polar form. Now if I want to convert this polar form back to a complex form, how you will be writing? Again, print, instead of phase you write it, I need it in a rectangular form. Rectangular form or complex form is same. So rect is the keyword. Let me copy this. I am copying and pasting this inside this. Print c dot math. I think one extra caliber is there. I think I made some mistakes in the braces. Yeah, I have given some. Let me remove this, and yeah, this part will also be removed. So let me run this now. C dot react. Okay, unexpected UFP of okay. I have left one curly brace here. Okay. Parenthesis has been given. So 2 plus 3, I got the rectangular form. So now you understood how to represent a complex number. 1. How to take the phase of a complex number. How to get the polar form of a complex number. And how can we convert a polar form to a rectangular form. When you study about list concepts, when you study about for loops, you can pass list of polar values in a tuple format. In each and every tuple you can pass these values and you can make a list of tuples and you can pass and you can run a for loop for that, and thereby you can convert all the polar values into a rectangular format. It makes your task very easy, right? This is one of the way. And another one is like sine value. You can also calculate the sine, cos, tan for your complex functions. For example, if I am going to calculate the sine of the same math dot react I have given, right, c dot, and for the same let me write it in this way. Code print c dot math. Let me write it as c dot math, sorry, c math dot sine of the complex number 3 plus 2j. So the sine magnitude of this complex number will be given, output will be in a polar form. It takes a complex number, it gives a polar form. So this is out. And two more things in the normal mathematical calculation which are available inside the math functions. One is about a GCD, which gives you the greatest common divisor. So I just failed to mention in that. But again, if you try for LCM, this will not work. For GCD you got 8, right? Because 8 is the highest common factor that divides 24s and 40. But you will not get a value for LCM that has been recently removed from this version. I just made this Jupyter notebook 1 month before, and today I sat for the shooting. At that time I got all these values, but now I'm not getting the accurate. In the recent days they actually removed certain patterns. So I've made a note what are all the things they actually removed and how we can logically implement them without using a standard functions. So LCM is not getting implemented, and similarly we have also worked and we found that it's not working for combination. For combination it is not working, for permutation it is not working, for certain features it is actually lagging. Yeah, we'll trace them in future. So there are lots of other complex mathematical functions available, but these are the most important mathematical functions that we apply for a complex unit calculation. So just make a note of it, make a separate paper, write a note of it and keep it, and it will be keep it as handy, and whenever you want to refer, as I mentioned, you can go to the Python documentation under math module and you can study all these things. Thanks for watching my video. We'll meet you in the next episode, and don't fail to subscribe my channel.